Alright, let's start with the givens of this question, which will definitely be on a test or an exam. So, something that is mentioned is M1. Well, M2 is mentioned in the question, but I did not write it. So M1 given M1 equals 2.5 kilograms and M2 equals 4.4 kilograms, as I labeled M1 and M2 here. What is also given is the value of the coefficient of friction, which is 0.33, and they do not have units. And what we're looking for is acceleration, so A equals question mark, because we don't know it yet. So let's start by drawing free body diagrams for them. So I'll start with M1 here. Okay, so we'll draw a little dot, and we have friction. We have tension. We have the normal force, like this, because it is on an incline and it always points up. It always points perpendicular to the surface. And then we have gravity, which always points down, and that leaves these two, which would be Fg with respect to y and Fg with respect to x. These are very important when calculating something like this. So this is M1. And for M2, it's much simpler, so we just have a dot. We have Ft, and we have Fg. And let's give this a reference point, so we'll do it this way. So going down to the right is positive, and going this way would be negative. So that's the easiest way to give a reference point for this type of question. Oh, and we have to, there's an angle here. Well, actually, the angle here gets transferred, if I'm not going to go too into it, but it goes into here. So this is 27 degrees right here in this corner. Okay, now let's start by creating a system of equations, which is always the best way. There are easier ways to solve this, but this method also works in university. That's why I always preach using this. So let's start for M1. Let's create a system. So for M1, we have to always write F net 1 equals M1A. Then we have Ft minus Ff minus Ff minus Fgx equals M1A. Now let's do M2. M2 would be much easier. It's just F net 2 equals M2A, which is just Fg minus Ft equals M2A. And now what we want to do is substitute them, because something I need to mention is the tension force between these two, between this pulley, is the same on both. So we can kind of eliminate Ft as a symbol here. So let's rearrange equation 2. So Ft would be, so it'd be negative Ft equals M2A minus Fg, and Ft equals Fg minus M2A. So now we have equation 1 and we have equation 2. So now what we do is sub in equation 1, or equation 2 into equation 1. So sub 2 into 1. And this would be, so Ft would go into Ft, so it would be Fg minus M2A minus Ff1 minus Fgx1, and Fg2 equals M1A. Okay, now let us continue. Okay, so now as I brought this over to the next screen, we have Fg2 minus M2A minus Ff1 minus Fgx1 equals M1A. And as we can recall, and we can go back to the reference in the diagram, we have Fg2, which would be M2G here, would be M2G, and M2A would be, well, actually, we'll bring that to the other side. So FF1. FF1 is mu Fn1, as we recall from the formulas, minus Fgx1 would be fg sine theta, and we bring that m1a plus m2a. And give me 1 second, let me bring over the diagram so it makes more sense. Okay, so I brought this over. So the reason why we have fg sine theta, I just want to explain and elaborate. So fgx, so here we have here we have fgx1. So what we're looking for is fgx here. And as I said, the angle 27 degrees. So we know fg is right here, and fgx is across. So we use sine, because it's opposite, opposite, and then hypotenuse. So we have sine theta. So as we get here, we're at m2g minus mu fn1 minus fg sine theta equals m1a plus m2a. Now we can get into plugging the numbers. So 4.4 times 9.8 minus 0.33, and fn1 can actually be turned into, here, actually before I do any calculations, let's turn fn1 into something. m2g minus mu, and fn1 can actually turn into mg cos theta. And then fg sine theta is mg sine theta equals m1a plus m2a. And this is the final equation that will be used to get the answer. So the reason why fn turns into mu mg cos theta, so fn is right here as we can see, and it is opposite, or it is parallel to fgy. So the value of fn and fgy are the same for any type of incline question, not even relating to pulleys, just in general. So fgy and fn are equivalent, the same value. So to find fgy, pretty much, which is fn, we would have to do mg cos theta, because fg we can find as fg equals mg. And then we need fgy. So 27 degrees here, so we got adjacent over hypotenuse, which is cos, the cos theta, cos relationship. So now we can get into plugging. So m2 was 4.4 times 9.8 minus 0.33 times, this would be m1g and m1g. So would be 2.5 and 9.8 cosine of 27 minus m1 again, so 2.5, 9.8 sine 27 equals 2.5a plus 4.4a. So now, if you plug this straight into your calculator, you would get 43.12 minus 7.204 minus 11.122 equals 6.9a. And that would be 27.794 equals 6.9a. Let's divide by 6.9. So a would equal 3.6 meters per second squared. Therefore, the acceleration of the system is 3.6 meters per second squared. Now let's move on to the next question. Moving on to part B of the question. So it asks us for a free body diagram, which we already did, but I'll just do it again. So we got Ft and Fg, and this is for M2. So we know that down is positive and up is negative, as we already established in part A. So now we're going to do something that makes it very easy. So instead of redoing everything, we can just use equation 2. And instead of copying it down, I'll redo it. So remember we had F net 2 equals M2A. And F net 2, the net forces, total to Fg2 minus Ft equals M2A. And remember, Ft can be the same. You can also use equation 1, but equation 2 just has less variables, so it makes it much easier. So now let's rearrange. So Ft equals, it equals M2G minus M2A. And remember, I'm just using, I'm just changing this Fg2 into M2G, which would be just be Mg. So Ft equals, what was it, 4.4 times 9.8 minus 4.4 times the acceleration that we just found. the acceleration that we just found was 3.6 meters per second squared. So now we got, let's use a calculator, we got 4.4 times 9.8, which is 43.12 minus 4.4 times 3.6, which is 15.84. Sorry, let me just fix that. So 43.12 minus 15.84 is 27.28. So let's round to the nearest tens, or we can just do up to 3 sig digs. So Ft equals 27.3 newtons. So that is pretty much how you solve the question. And if you need any help, just feel free to leave a comment.